Hey guys, welcome to College United Engineering with Bongani Gomez. So today we'll be doing latching in PLC ladder. Yes. Okay, so we see what is latching. Latching simply means to keep an output on even after the input signal like a push button is released. Okay, so writing a instruction for output, and we'll say out y1 and y0. Okay, and then we're gonna call this one motor. Yeah, we'll call it a motor. And then we are going to write our input, which will be our push button for start, but as a start, and we'll call it LD X0. Remember that the push button, which is a start button, is always normally open, so LD means normally open. Okay, and then now we're going to write our stop button, which will be the instruction will be LDI. So LDI means normally close, so we'll call it X1. Okay, because of your inputs are always X, okay, and your outputs are Y, so say X1. Okay, then we can call this one, say, edit device command, and we call it a start. And then this one we'll call it a stop. Okay, so now we say code, which means compile, and then we go online. Okay, so now okay, let's go online. Okay, and then we are online, and we go run mode. Yes, continue. So now this is your motor. So when we come here and we say set on, okay, our motor is running. Okay, but now when we latching means to keep on your motor or your output on even after the input signal, which is your start, your X0, is released. So at the moment it's not released, it's still set on. So if I set it off, which means if I release the input signal, your motor must not stop, but here it has stopped. Why? Because of there's no latching circuit. Okay, so now let me set it on, and then this is our stop, and then if we set it on, it means that our motor will stop. Okay, so this is a stop button. So remember, a stop button works in such a way that it's always normally closed. That's why we only set on our X0. So now let's go offline first, and then we are going to do the latching circuit. Okay, so for us to design the latching circuit, what we need is to come here, and we add a line going downwards, and then we are going to add a instruction, and this instruction must contain a register for your motor. Okay, this is what I mean. So we are going to put a normal open here in such a way that when your Y0 energizes here, it will become a normally close, so that it can keep on energizing your motor. Okay, so we are going to say LD, which means normally open, of Y1. Okay, so this is the same address. See, Y0, no, we have to say of Y0, sorry for that, Y0. Yes, so this is the same address, Y0, Y0. So if this motor energizes here, it will become a normally closed, so that it acts as a retainer. Normally we call it a retainer in motor sequences, but here we can call it a latching circuit. Okay, so now I can code, or you can always use compile. Okay, So now let's go online and say yes. Okay. Yes. Okay. Okay. Yeah. So now, okay, let me start. In fact, let me just stop the whole process. Sit on. Okay. So if I press this start button, or if I set it on, what happens that your output or your Y0 becomes energized. Okay. And we see that also here your Y0 is energized, is now in other words a normally closed. Okay. So if we release the start button, which is saying set off, what happens? Your motor is still being energized via this Y0. So this Y0 is making sure that your motor remains energized. Okay. So this is what latching is about. Okay. So latching is just a process whereby you keep on, or you make your output to be on even after the input signal, like a push button, is released. Okay. So that's what latching is. So but besides latching, what we can do, we can always use internal memories like M1000, LDM1000. So LDM1000 is an instruction, or it's an instruction that is always on, or should I say it's a register that is always on when your PLC goes into run mode. So instead of using the latching circuit, you can always use your M1000, and you say let's have another output. We'll say Y1. Okay, and our Y1 we'll call it let's say motor 2. Motor 2. Okay. So now let's go online. Okay. And say recover. No, don't recover. Okay. So now you see here where it's written stop is simulated, means that our PLC is on stop mode. Okay. But immediately when I put it on run mode, your M1000 will always be energized, and then your motor 2 will always be on. So we don't use a latching circuit in this situation. Our M1000 will always make sure that our Y1 is always energized. Okay, let me go to run mode, and that's it. Our motor 2 is energized, always energized. So you see your motor 2 can always be energized without using the latching circuit, but using internal memories of the PLC. So your M1000, it's always on when your PLC goes into run mode. So we can continue and add something like a stop button also here. We'll call it LDI. Remember, LDI means normally closed, and the stop button is always normal closed, and we'll say LDI X2. We've already used X1, so we won't use X2. We won't use X1, we have to use another X after 1 or greater than 1. Yeah. So we'll call it stop 2. Stop 2. So let's go, let's compile. Okay, and we go online, say yes. Nope, don't recover. So yes. Now our PLC is in stop mode, so let's go to run mode. Immediately our motor 2 will start. I say yes. So our motor 2, and then we can come and start our motor 1. We press the start button, but now you have to release it. So your motor 2, your motor or your Y0 is being energized via the latching circuit. But now me, I'm using M1000 now. See, M1000 always on. So you see my motor 2 now is receiving power, or is energized. But now we can stop it by setting off our, no, it's setting on our stop button, and then our motor 2 has stopped. Okay, so you can just use M1000, or you can use the latching part, or the latching circuit. So yeah, that's it. Let's meet on the next video. Don't forget to like, subscribe, and share.